Hello, my name is Tyler Corrales, and to whom it may concern, I would like to briefly talk to you about per and polyfluoroalkyl substances, colloquially known as PFAS, and even sometimes referred to as forever chemicals. Per and polyfluoroalkyl substances are chemicals found in commercial, industrial, and consumer products. For the average person, you will find them in items like water-resistant materials such as rain jackets, umbrellas, etc., nonstick cookware, cleaning products, personal care products such as makeup, shampoo, nail polish, dental floss, etc., stain-resistant coatings in things like furniture and upholstery, and many more. PFAS are relevant right now due to their industrial use and recent discovery of their presence and persistence in the environment. The chemical structure of these substances is crucial to their ability to resist breaking down in the environment. PFAS are aliphatic molecules, which refers to the presence of a straight or branched carbon backbone bound by hydrogen atoms. However, PFAS aren't bound to hydrogen, rather these atoms are replaced by the element fluorine. This is where the prefix comes from. If the hydrogen atoms are completely replaced, the prefix becomes per, as in perfluoroalkyl substances. And when partially replaced, it is denoted as poly or polyfluoroalkyl substances. The significance of this configuration is the inherent strength found between carbon and fluorine bonds. CF bonds are one of the strongest bonds in organic chemistry, requiring a massive amount of energy to break. Beyond this, the chemical substances are very polar due to their carboxylic or sulfonic acid functional groups. Because of this polarity, PFAS are very soluble in water. The combination of these two qualities suggests that PFAS are very stable and are resistant to things like sunlight, heat, acids, bases, and microbial attack. Which is why the chemicals are able to persist in the environment, because they do not naturally break down. In fact, it's worth noting that chemicals like PFOA, a variant of one of these substances, actually have a half-life of 5.4 years, while other related compounds range up to 8 years. The bioaccumulation of PFAS in ecosystems can have negative effects on the soil. By altering the microbial availability and disturbing enzyme activity, the chemicals are able to reduce the quality of the soil. A study conducted by Sun et al. Confirmed that soil contaminated with PFAS has less bacterial diversity. Now, this is particularly harmful because bacterial diversity contributes to nutrient cycling and assists in breaking down organic material in soil. Typical point sources or identifiable sources of pollution include wastewater treatment plants and landfills. This is because these facilities are the destination of wastewater collected from households, industrial plants, military bases, and airports. Studies show that concentrations of PFAS have been measured in the surface water near military bases and airports due to their frequent usage of aqueous firefighting foams, which contain the compound perfluorooctane sulfate, or PFOS. Current water treatment techniques are ineffective and lack the ability to destroy and remove PFAS from water. This means that following treatment, these chemicals are being redistributed back into local bodies of water or become concentrated in landfills in the form of biosolids, or sludge. Water remains one of the most common pathways for human exposure to PFAS. This is surprising as to why there's no current or enforceable law limiting the concentrations of PFAS chemicals in water. PFAS are actually first discovered through the identification of PFOS in wildlife. Since then, scientists have found PFAS in the blood of humans and animals in various concentrations all over the world. Testing on animals has since revealed that humans do not react in the same way to the chemicals. However, scientists have come up with methods to extrapolate data on animals to humans. This process has been useful for understanding potential protective measures that need to be taken, although further research needs to be conducted. Studies on animals have indicated high concentrations of PFAS affect development, immune response, and as well as liver function. In terms of health effects on humans as a result of PFAS concentration in the body, no conclusive study has been conducted. Along with this, it is to be said that not all chemicals elicit the same response in humans and animals, and nor has every PFAS been tested, given that there are thousands. With that being said, studies have made strong correlations with high concentrations of PFAS with increased risk of thyroid disease, lower infant birth weight, increased risk of preeclampsia during pregnancy, decreased bodily response to vaccinations, high cholesterol levels, as well as an increased risk of cancers. There is sufficient data to establish that concentrations of PFAS in the body result in negative health outcomes in humans and animals. However, the significance of this risk is unknown with current research and data. PFAS pose a serious public health and social issue for the future. Currently, these chemicals are under-researched, therefore we do not currently possess the knowledge of their potential to harm humans and animals. Yet, we are continuing to find point sources of PFAS, as well as measure their presence in ecosystems as they bioaccumulate. Not only that, but these chemicals are being found in nearly every item we use on a daily basis. Some may counter this argument by acknowledging the limitations and attempts that have been made to phase out substances like PFOA and PFOS. However, comparable compounds like PFAA and other chemicals are still used in various industries. This event calls for more regulations and the need to limit the use of PFAS in large industrial plants. Not only that, but national guidelines should be established to restrict the concentrations of PFAS in the drinking water. We cannot hold companies accountable if thresholds like this do not exist nationally. These chemicals also bring awareness to the quality of our current water treatment techniques, as they are unable to remove or destroy PFAS. Lastly, the lack of information on the effects of health outcomes suggests that research be focused on this area of study. Thank you.